Be doing solving quadratics by factoring. So today we'll be reviewing the factoring techniques that we'll be using. The first one is pulling out the GCF, the greatest common factor. The second one is factoring a trinomial using the product sum game. And the third one is factoring a difference of squares. All right, let's start off with the very first one, pulling out the greatest common factor. This is an important one to learn because a lot of other factoring techniques are based on it, and this is the technique you always want to try first when you look at a problem that you need to factor. All right, first you need to look at how many terms you have. In this case, we have 3 terms. 1, 2, 3. You can always tell the terms are separated by the pluses and the minuses. All right. The first thing we have to do is determine what is the GCF, the greatest common factor of these 3 terms. And what we're doing there is we're trying to figure out what's the largest thing that will divide these 3 terms. The answer is going to be 6x to the third. 6 divides 24, negative 12, and 18 evenly, and x to the third divides x to the fifth, x to the fourth, x to the third evenly. Again, 6x to the third is our GCF. 6 divides 24, 6 divides negative 12, 6 divides 18. And it's the largest thing that will divide those evenly. And x to the third you could take from each of these terms. Now what you need to do is leave what's left over after taking 6x to the third away from these. We'll be dividing all of these by 6x to the third. You'll want to leave the leftovers in parentheses. All right. If I take 24, divide by 6, I get 4. If I take x to the fifth and divide by x to the third, I get x squared. So that's what's left over when I take the 6x to the third away from this by dividing. Now we move to the next term. Negative 12 divided by 6 is negative 2. X to the fourth divided by x to the third is x. So if I pull out the GCF from this term, I'm left with a negative 2x. Finally, looking at the last term, 18 divided by 6 is 3. X to the third divided by x to the third is 1, which means that you'll be left with no x's. So again, 18x to the third, you take away 6x to the third, that leaves you with a 3. So we're done. We have factored this polynomial into these 2 factors. One is 6x to the third is the first factor. 4x squared minus 2x plus 3 is the other factor. If you multiply these 2 together, you'll end up with this again if you want to check it. So there, we've just factored using pulling out the GCF. Let's move on to the next technique, which is factoring a trinomial using the product sum game. This technique is the longest and the most difficult, so you'll want to pay close attention. You'll want to use this when there's 3 terms, x squared term, an x term, and a number term. This is a good time to use the product sum game to factor a trinomial. You'll first start off by multiplying the x squared term times the negative 10, the number that's by itself. We referred this to the a and this to the c to get a product. So again, you always start off by taking this number and multiplying it times that number. The x squared coefficient times the number that's by itself. 6 times negative 10 is negative 60. That's going to be our product in the product sum game. The sum in our product sum game is always the x coefficient, b. Now that you have a product and a sum, you have to play the product sum game. This is fairly difficult for some students, but for students that are good with their multiplication tables and addition tables, it should be a little bit easier. All right. What we're going to try to do is come up with 2 new numbers that when you multiply the 2 numbers together, they give you negative 60, and when you add them together, they give you negative 11. We're trying to come up with 2 numbers that have a product of negative 60 and a sum of negative 11. Some of you can do this in your head, but if you have problems, I suggest you look at all the possible products. So we're going to write down all the possible products. I know the 2 numbers that I have, one is going to be positive and one is going to be negative because this is negative 60. I like to look at the possible products systematically, starting with 1. 1 and negative 60 is a product gives you a product of negative 60. But this is not our answer because these two don't add together to give us negative 11. Let's try again. 2 and negative 30 multiply give me negative 60, but again, it doesn't add together to give me negative 11, so we'll have to try again. 3 and negative 20 multiply to give me negative 60, but they don't add together to give me negative 11. Let's try again. We finally found our two numbers. 4 times negative 15 is negative 60. 4 plus negative 15 is negative 11. So these are the two numbers that will help us finish the problem. All right, what are we going to do with these two numbers? We're going to take these two numbers, the 4 and the negative 15, and we're going to use them to replace the negative 11. So instead of negative 11x, we're going to replace it with 4x minus 15x. So we take the 4 and the negative 15, put x's on them, and we take this term out and replace it with these two terms, which is perfectly legal because 4x minus 15x is the same as negative 11x. So really, this expression are still the same. You'll want to separate these into two groups now. We'll put the 6x squared and the 4x in one group, the negative 15x and the negative 10 in another group. What you'll do next is you're going to pull out the GCF here, and you're going to pull out the GCF here out of each group individually. When you do them, you have to be careful, though, because you'll want your leftovers, the terms in parentheses, to match. All right, 6x squared and 4x, if I pull out the GCF, I would pull out a 2x. 6 divided by 2 is 3. X squared divided by x is x. 4 divided by 2 is 2. X divided by x is 1, so there's no x's. Now you're going to pull out the GCF of the second group. Now remember, the leftovers have to be 3x plus 2. So what would I pull out of these two terms to leave me with a 3x plus 2? A negative 5. If I pull out a negative 5 out of negative 15x, that'll leave me with a 3x. Negative 15 divided by negative 5 is 3, and then the x is still left. If I pull a negative 5 out of a negative 10, negative 10 divided by negative 5 is plus 2. This is good because, remember, this parentheses has to match this parentheses in order to continue. If they don't match, you might have to try to pull out something different, or maybe change the sign. But it's very important that these two match for you to continue. All right, now to find our two factors. One factor is the 3x plus 2, the two things in parentheses that match. The other factor is formed by the two things you pulled out, the 2x and the minus 5. All right, there you have it. We've factored this into two factors. One factor is 3x plus 2. The other factor is 2x minus 5. And again, if you want to check if these are the correct two factors, you could always multiply them back together, and it should equal this. Let's move on to our last method, difference of squares. All right, when you're using difference of squares, the most important thing to remember is it's got to be a difference, which means subtraction. You could only use difference of squares if this is a minus, and then you could these things are perfect squares. When you use difference of squares, the two factors will always have a plus in the middle of one and a minus in the middle of the other. Just like this. What goes here and here will be the same. What goes here and here will be the same. All right, to figure out what goes here, we're going to look at this and say, what would we have to square to get 4x squared? Well, that would be 2x. So 2x goes here and here because 2x squared is 4x squared. What goes here and here is what we have to square to get 49. And there you have it. Factoring using different squares. It's really quick and simple, but remember, you have to have a minus here to use difference of squares to factor.